Good morning, everyone. Today I will be presenting my critical review of the paper that is titled Top Data Mining Tools for Healthcare Industry. Uh, here I've provided the reference in the APA format. So the focus of this paper is highly relevant to modern healthcare, where massive volumes of complex data such as medical records, sensor data, and clinical notes are generated every day. Choosing the right data mining tools is not just a technical decision, but one that directly impacts efficiency, accuracy, and decision making in healthcare systems. So in this PDF, I have created 4 sections. The section 1 is the summary of the paper. Section 2 is the critical analysis, and section 3, which discusses the questions of this research. So we'll start by section 1, which is the summary of the paper. At first I provided the reference in the APA format. So what's the purpose and the research problem? So the main purpose of this research is to analyze and compare popular open source data mining tools specifically for the healthcare applications. Healthcare data is extremely challenging. It is large in volume, it's diverse in format, and it's often unstructured and noisy. Because of this, organizations struggle to identify tools that can handle real world medical data efficiently. So instead of guessing or relying on popularity, the authors argue that tools should be evaluated based on how well they meet healthcare specific needs, such as scalability, usability, and flexibility. So, the core research problem here is how do we choose the right data mining tools for healthcare environments based on actual requirements rather than assumptions. So for the related literature, uh, the paper builds on earlier research in healthcare analytics and decision support systems. It highlights common data mining tasks in medicine, including classification, clustering, association, association rule mining, and anomaly detection. The previous studies emphasize how healthcare data grows rapidly and comes from multiple sources, making analysis very difficult. By referencing these works, the authors establish a strong foundation for why evaluating data mining tools in healthcare is both necessary and timely. The third section is research design and strategy. So instead of running experiments on real patient data, the authors in this research used a survey based comparative approach, and they evaluated 5 widely open source tools. These are the KNIM, the Rapid Miner, the R, using RStudio, Scikit-learn, and Apache Spark. Each tool is assessed using the same evaluation criteria, which includes the ability to handle large datasets, the data integration and preprocessing, model building, visualization capabilities, and ease of use. This consistent comparison helps future fairness even though no direction performance benchmarking was concluded. Now comes the results discussion and conclusion. So the findings show clear distinctions between tool types such as the KNIMP and the Rapid Miner stand out for the healthcare professions because they use visual workflow based interfaces. They are beginner friendly, they scale very well, and they include many built in features. The R and the scikit-learn offer great flexibility and customizations, but they require strong programming skills. On the other hand, Apache Spark is particularly strong for handling very large scale healthcare data, especially in distributed environments. So, the key takeaway is that no single tool is the best for every scenario. The ideal choice depends on the size and type of data, the technical skills of users, and the project goals. So for the contributions part, the one of the most valuable and contributions of this paper is that it provides a clear framework for selecting healthcare data mining tools. Rather than promoting a specific platform, the study acts as a practical guide, helping the practitioners match tool capabilities with real healthcare needs. Uh, it makes it especially very it's very useful for the hospitals, researchers, and the healthcare IT teams working with very limited budgets and open source solutions. So that concludes the summary of the paper. Now I'm going to discuss the second section, which is the critical analysis. So overall, the paper is well organized and clearly written. Um, the strengths includes the it focuses specifically on healthcare, not general analytics. It uses consistent evaluation criteria, and it provides practical, easy to understand insights. What are the limitations? You say no real world medical data sets were tested here, and it lacks performance benchmarks such as speed or accuracy comparisons. Including hands on experiments or case studies, it could have strengthened the findings further. So, for the future research directions, the author suggested several future directions. These are like testing tools on real hospital datasets, comparing modern deep learning and AI based tools, exploring hybrid approaches that combines multiple tools. So these such extensions could provide a deeper insights in performance, usability, and real-world effectiveness. So based on this, in the section 3, there are also some questions, which is like what might shift in the results. Should keep today's deep learning tools enter the mix alongside massive AI systems? Would older methods still hold up when stacked against current tech built for heavy computational loads? And my second question is what if mixing several data mining tools worked better for messy healthcare records than sticking to just one system? Maybe layering methods handles tangled medical details more smoothly instead of better betting everything on a lone platform using many uh, could untangle patterns hidden deeper. Pile different techniques together, suddenly odd gaps in patient's history start making noises, making sense. One tool misses quirks and other catches right away. Toss in variety, reduce blind spots. So, does the patchwork analysis beat a solo engine when the data breathes unpredictably? So to conclude, this paper highlights the that selecting data mining tools for healthcare is not about choosing the most popular option, but about choosing the right tool for the right context. By aligning the tool capabilities in the healthcare needs, the organizations can improve data-driven decisions that to make the ultimate decisions when it comes to like enhancing patient outcomes. Thank you everyone, and I'll be happy to discuss any questions.